in example number 2, what we're going to do is we're going to model some more data. This time we're going to model it with a logarithmic data or logarithmic function. So what we're going to do is we're going to look at how do we predict which one's going to be logarithmic and which one's going to be exponential. And again, it's by the shape of the graph. What kind of growth are we seeing when we look at our scatter plot? So the very first thing we have to do is we have to make sure that we put this data into our calculator correctly. So that is going into your stat and editing the list. Now, one of the things that we have to make sure that we do is we have to read these directions carefully, and they say what X represents. We're going to let X represent the number of years after 1900. So then 1950 will be 50 years after 1900. So our first value is going to be 50, and then we got 60 years all the way up to, by the time we get to 2005, we're 105 years later. So that's one of the things I went through, and I didn't do it correctly. I started at 1950 at year 0 and so on, and then that doesn't give me the appropriate regression. So make sure you read what X. Sometimes they're very good at telling you what that needs to be so that you can get your data entered in correctly. So assuming I have my data entered in correctly, which it is, then what we can do is we can go ahead and think about making a scatter plot. Always devise and set up your window so that you can get a good viewing window. Remember that X was 1900, which was at year 0. We're going up to year 2005, so I need to increase that limit a little bit. So I've got to get up to at least 110 years. Gets me a little bit beyond that. We'll go by 10-year increments. The Y scale, what I wanted to do with the Y scale, since I only have values go from 68 to 77, I went from 60 to 80 so that I can see that data a little bit more clearly. Otherwise, they're going to be very small in there, and you won't see much of a change at all. So in essence, I should have my scatter or stat plot all set up, my scatter plot for list 1, list 2. It's all in there. So next thing I'm going to do is I'm going to clear out that just for a moment so we can see the scatter plot. So here's our scatter plot. It really almost looks linear, so if they didn't give us the information that we're supposed to do a logarithmic model, we might even be thinking that a linear model fits this data well. So we're going to go with their directions. We're going to do a logarithmic regression, and we're going to do a stat. We're going to calculate, and we're going to go down till we get a natural logarithm regression, so that's the LN reg. So we do the LN reg. Oops, got a little interruption there. The natural log regression. We hit enter. We got to tell it's on list 1, list 2. We don't have a frequency list. Store this, and this time I want to make sure I store it in list 1 or Y1, just like I did before. So hit your bars. Tells you what variable you're going to store it in. You want to store it in a Y equals variable. So put Y bars, and then we want it in Y1 again. I just kind of like that as a natural as a default. We want to calculate this regression, and then we want to kind of look at our correlation coefficient again. So we got a fairly high correlation coefficient. We got a 0.987. The closer you get to 1, the better it is. That looks like a good fit. So let's go ahead and graph that. It should have pasted it. I'll just double check. It should have pasted that equation in, and there is one pasted in the graph. And we'll see just how good of a fit this is. Now that's a pretty tight fit. We see that it's going through the points and it's approximating the pattern that we have. So that's the first thing. And what we're going to have then is this equation that we can record. Bugger, where'd it go? I'll get it right back here. So what our equation is going to be, our life expectancy based on years is going to be, and maybe I'll write it as a function notation this time. The life expectancy based on the year that you have is equal to, and then I got to come back and try to keep writing these in there. 15.09 plus, and then our value of V is 13.38, and the rest of our equation is natural log of X. So this is the, since I got Y in there for years, natural log of Y would be more appropriate. So this equation is supposed to model life expectancy based on the given year that you give it after the year 1900. And now they ask us, then use the function to predict the life expectancy for a person born in 2020. So 2020 is going to be 120 years later. So that's going to create just a little bit of a problem with the way that I have my window set because I don't get out that far. So first thing I'm going to do is I'm going to increase that window. We're going to go out to 120, so maybe 130 years to make this prediction and get our graph to go there. And here comes our prediction line. And I want to see when it's 130 years later, so I'm going to hit a trace. I don't want my plot. I want the Y1 where this is the prediction line. and we want to type in 130 years later, and that should predict in the year 2020 we expect people to live to a ripe old age of 80.22 years, which is a prediction that we have based on the model. So approximately 80.22 years. So again, similar ideas to what we do with the exponential model. We just had to do a logarithmic model and then do the appropriate regression and record the equation and then do the interpretation of the question that they ask us at that point.